using the sample, we found an interval. What is that interval?
The 95% confidence interval is mu is in between 1.6 and 2.26.
And how did we find that interval? There was a process, right? First we had to find the
mean and standard deviation.
mean, standard deviation, critical value, then margin of error. But in order to find the margin of error, we need one more thing, standard error. The standard error is simply a formula, which is S over square root of n. Where do we get the critical value from? The chart, or what function they calculate? Inversely. I'm going to make the process completely automated, and let's see if we get that interval. I need the data though. Who's going to volunteer? How many observations we had? We had a lot, so let me just enter those. So pick up your calculator. Pick up your calculator and start entering the data in list 1. So all I'm doing is taking all the observations that we had last time, putting it in list 1. Are we ready? Okay. Second mode to exit. Press start. Over to tests. In my calculator, it's option number 8. It should say T interval. What do we have? Do we have the data, or do we have a bunch of statistics? We have the data in list 1. If you don't have the data, but if you just had stats, then you'd have to enter the mean and the standard deviation of the sample. We know how to find the mean and the standard deviation. So you just have to put in the mean, standard deviation, and the sample size. Since we have the data, I'm going to enter it in list 1. What just happened? Okay. The data is in list 1. The confidence level that we set is 0.95. Do not put 95 there, it's not in percent, it's a decimal. So 0.95 and hit calculate. That's it. So 1.6, 1.5916, 2.26, 2.26. Yes? So if you have the data, you could find the interval easily using a calculator. This one and the one that I'm about to do next. Both of them are very straightforward. But it is not about putting things in the calculator, it's about whether you can interpret the interval properly. And also, when you do the homework or on the exam, it would just ask you to come up with a critical value or just the standard error and so forth. So you've got to understand the process. But you can always verify your answer using that. If an interval is all that we want, use the calculator. Yes.
Can you repeat what you said after you go to tests?
Option number 8. And it should say t interval. If it's not option number 8, just pick the one that says t interval. Good? So what would you do if you had a different confidence level? Change that 0.95 to something else, maybe 0.9, maybe 0.8, whatever you want to change that to, and that is going to give you a different interval. Does that make sense? Yes? Before we move on, what do you expect to happen if you keep on increasing the confidence level? Would the interval widen or would it narrow?
It would narrow.
It would narrow if you increase the confidence level?
Yes.
Why?
Well, if you have a higher confidence, you can't have a larger range that you're confident that the mean is going to be in some range. So the higher you're confident, the less range you have to show like you're confident of that.
Okay, so that's for 0.95. That's for 0.99, so that's the 95%. Oops, 99% confidence interval. That is between 1.47 less than mu, less than 2.38. Benson, did it narrow or did it widen?
It appears I'm wrong.
Oh, it appears you're wrong? Well, it is appearing clearly. Your glasses are working. So it widens, but I do understand where his thought process is coming from. Well, if you are more confident about something, you have to estimate it in an accurate sense. But why does it widen? Well, think about it this way. If I said, okay, it has to happen between 1.6 and 2.26, and it doesn't happen between 1.6 and 2.26, then I'm wrong, yes? But if I want to be this complete smart person, and I don't want to be wrong at all, I could simply say, I'm extremely confident that the average time would lie between 0 and 10 hours. Would I be wrong? Yes? Would I be wrong ever? Based on the sample? No. So I've become extremely confident by saying 0 to 10, but is that informative? Or is it downright stupid? What is the purpose of statistics if you're just going to say, oh, it's going to be between 0 and 100, have a nice day, right? Doesn't make any sense. Going along with what Benton said, we would like to achieve an interval as accurate as possible for 99%. In other words, given two options, if I have two different intervals, both at 99% confidence, Suppose you collected two samples. One sample resulted in the interval that's in blue. Let's just say it's from 2, 1 to 2. And the other one, it is in orange. That says it's between 1.3 and 1.4. Both of them will have a confidence level of 99%. Of the two, which is better? The one in orange or the one in blue? Do you follow my question? So both intervals use a confidence level of 99%, but it's coming from two different samples. And one of them is narrower than the other. Which one is better, the one in orange or the one in blue? James?
The one in blue because it covers more data.
The one in orange?
The one in blue.
Why?
Because it covers more data. Typically.
Okay.
I think neither one is better because both of them are still covering 99% of the data.
Okay. Any other answers?
I was gonna say orange because I thought it'd be more narrow.
So the one in orange is more accurate. The reason being, it's extremely narrow, right? So you're getting more and more confident and you're saying, okay, it's between 1.3 and 1.4, and it is a very narrow interval. So going back to what Benton said, what we want is a narrow interval. That is true. But you can't achieve it with a single sample. The only way you can widen and narrow an interval is by changing the confidence level. But that is not the right way to do science. If you keep on repeating the process and you end up getting an interval that is very narrow with a different sample at the same confidence level, then you're actually getting closer and closer to the truth. Does that make sense? Yes? But getting a good sample is key. The same 5-step process. The very first step is to collect a sample. Second step is to find the sample statistic. And choose alpha or C level. Last time it was X bar and the standard deviation. This time it's simply p hat. And that would be X over N. N would be the sample size and X would be the number of observations that favor the sample size N. I'll do an example and it'll make sense. Last time we had a formula for standard error, which was S divided by square root of N. This time it is square root of p hat times 1 minus p hat divided by N. We found the critical value last time. What did we use to find the critical value? Either the chart or inverse T function using the calculator. Here we have to use So Last time, critical value was obtained using a a t distribution. Here, it is standard normal with mean 0, standard deviation 1. We know the standard error. We know the critical value. What should we find next? Fifth letter of the alphabet.
Margin of error.
The fifth letter of alphabet is margin of error.
Well, you change the margin of error, doesn't it?
Generalization, you're not getting it. It's okay. I know where you're going with this. It is the margin of error, but it's E. So we find the standard error using the formula, which is quite easy. Critical value, we've got to get it using a calculator. And once we find that, we can multiply it to get the margin of error. Once we have the margin of error, the interval for P is P hat plus E, less than P, greater than P hat minus E. Last time, this was x bar minus E. That was mu, and we had x bar plus E. This time, it is P and P hat. And what other things changed? The standard error changed, and the critical value, the distribution where you get the critical value, also changed. So let's practice like we did last time with finding the critical value, because that is the tricky part. Once you get used to this, everything else is easy.
What does the X stand for? Is that the mean or?
That is the number of observations that will satisfy an event. For example, the proportion of students who like dyeing their hair, right? So I observed 10 students, and 3 of them said they like dyeing their hair. So it'd be 3 out of 10.
Okay.
Does that make sense? Yeah. We will do an example. So, just like last time, first we need the distribution, which is a bell curve. Zero is right in the middle. The confidence level for the first case is 0.9. In other words, it is 90%. If I have 90% in the middle, what percent is on either side or tail? 5%. And if the sea level is 0.9, what is the value of alpha? 0.1. It's just 1 minus 0.9, so this is alpha over 2. So in terms of a notation, last time we used t, now it's z. So 1 minus alpha over 2 on the right side. On the left hand side, it's z sub alpha over 2. The notation is important because it will let you know on what to put in the calculator. So here we have z sub 0.05 and z sub 0.95. Last time, the notation mentioned inverse t, alpha over 2, degrees of freedom. The letter z here denotes inverse norm. So in your calculator, all you have to do is type in inverse norm 0.25. And naturally, the value that you get, should it be positive or negative? Negative, it's below 0. What do we have? Negative 1.64.
Yeah.
Should we bother trying to find the other one also? No. Since we know this is negative 1.645, the other is positive 1.645. Yes? Good. So notation is important because if you understand this, that tells you what to put in the calculator. The letter Z means inverse norm, and what should you put next? Just 0.25. Usually we would type in inverse norm 0.25, mean, standard deviation. Well, the mean is 0 and the standard deviation is 1. If you don't specify the mean and the standard deviation, the calculator will assume that the mean is 0 and the standard deviation is 1. Does that make sense? Okay. Second, part B, 95% in the middle. So that would imply the area of each tail is
0.025.
0.025 or 2.5%. So if sea level is 0.95, alpha is 1 minus 0.95, which is 0.05. The area on either side is alpha divided by 2. In terms of notation, this would be z sub, what value? Alpha over 2, which is 0.025. And on the other side, it would be 1 minus alpha over 2, which would be 1 minus 0.025. You'll get 0.975. So you can either do inverse norm 0.025 to get the left critical value, or you could do inverse norm 0.975 to get the right critical value. And what do we get?
Negative 1.15.
96. Good. The last case. What is the amount of confidence in the middle? Is it 0.01, 1%? No, that is the value of alpha. If alpha is 0.01, what is the amount of confidence? 1 minus that, so just 0.99, in other words, 99%. If 99% is right in the middle, What amount do we have on either side?
0.005.
0.005. Which is simply alpha over 2. And it is the same on the other side. As a notation, over here, it would be z sub 0.005, and on the other side, it would be 1 minus 0.005, which is 0.995. So you can do inverse norm 0.005, or you can do inverse norm 0.995, which is 2.32. 58. And this would be negative 2.58. I mean, why would it be important to know this interval? Well, it completely determines, the majority of them like Apple Music, then if they're going to release an album or something, they better do it to Apple Music so that you make more money. So there are studies like this that are conducted pretty much every day at industry. So Target, Walmart, they all do it. So what is the proportion here? The proportion of interest is the proportion of students who prefer Apple Music. And that is why I called it using, or referred to it as the letter P. So we collected the sample already, so the first step is defined. The second step is to find the sample statistic corresponding to P, which would be P hat. And what is P hat? It is an estimate that we obtain from the sample, X over N. N is the total number of students that we observed, and X would be the number of students who prefer Apple Music. So that would be 11 over 30. What is it? 0.323? No?
0.37.
3737.
Goes 3666 repeating.
We'll just call it 37. Approximate. So is alpha provided to us? Yes, alpha is 0.05. That would imply 95% confidence. What is the next step? The next step would be to find the standard error. The standard error in this case it is square root of p hat multiplied by 1 minus p hat divided by n. What is p hat? P hat is 0.37 multiplied by 1 minus 0.37. 1 minus 0.37 is 0.63 divided by the sample size, which is 30. And what do we get?
0.080.
After square root? So the standard error is 0.088. reducing one step. The critical value is obtained using a standard normal distribution. So if we are looking at 95% confidence, what is the area on either side? 2.5%. And we know what that value is already. We found that value to be 1.96. You can use your calculator, of course, to find that using inverse norm, you get the same answer. What is the margin of error? The margin of error is always the product of two things, the standard error and the critical value. The standard error is 0.088. Did we all verify? Do we get the same answer? Yes. Multiplied by 1.96, and what do we get?
0.17248.
I'll be lazy and I'll call it 0.17. When you do the homework or on the exam, it will clearly state round to this many number of places. And as always, the more decimal places that you retain, the more accurate your answer will be. I'm just being lazy here because it'll be easier for us to add and make inferences. Good. And how do we find the interval we add and subtract the margin of error from the sample statistic, which is 0.37. So 0.37 plus the margin of error and 0.37 minus the margin of error. So we have 0.2 less than p less than 0.54. Clear? So the conclusion here is with 95% confidence, it can be concluded that the proportion of students who prefer Apple Music is between 0.2 and 0.54. This is Oftentimes people would say, okay, the population parameter is definitely going to be between 0.2 and 0.54 with 95% confidence. But there is a slight difference in interpretation when it comes to this interval that we have. This simply means if I went and collected 100 samples, 95 out of those 100 samples would give me an interval that would match, would give me a value p hat that would fall between 0.2 and 0.54. Does that make sense? So it's based on frequency of sampling. One of the methods that you learn here is called frequent statistics, which is based on resampling stuff. But there is a more complicated field of statistics called Bayesian, where you will get an interval with some prior knowledge where this would be actually accurate because of the prior knowledge that you have. Accurate with some level of certainty, 95% and so on. So do not misinterpret the interval. Always keep in mind, this means that if you go and resample and collect 100 samples, 95 out of those 100 would give a p that would lie between 0.2 and 0.54. Does that make sense? Okay. We have an interval, and we're going to make an inference or inferences using the interval that we have. That interval is formed with 95% confidence. So there is a 5% chance that I could go wrong, but that aside, so at that confidence level, Madison makes a statement that the proportion of students who prefer Apple Music, which in our case is P is not equal to 0.4. Is that a true statement from a statistical standpoint? I see head shaking in different directions. Is that a true statement?
Yes, because it's a range, it's not an exact number.
Okay. So statistically, could it be possible for it to be not equal to 0.4? Using this interval. Does 0.4 fall in that interval? So is it possible? Yes? If it is possible, could I say that? No. So that's not a true statement. Statistically. Could that be a true statement? Josie claims that the proportion is going to be greater than 10%. Would it be true? Yes. Whatever interval that we have, even at 95% confidence, is definitely bigger than 10%. 10% doesn't fall in that interval whatsoever. So that statement is true. Could it be greater than 75% as Melanie claims? No. The maximum amount that is likely to happen is about 0.54, and Melanie claims that it's going to be 0.75 and above, so that's a false statement. Does that make sense? So that is the basic layout of a hypothesis test, which is coming up next. But do you see how you make inference? So when I say true or false, I'm not saying, oh, this is it. All I'm saying is, from a statistical standpoint, is there significant evidence to support the statement or otherwise? That is all. Good? Just like how we did the interval for mean using the calculator, the interval for proportion, the entire process can be completed using your calculator. So press start, go over to tests, and so this is the same place where we will be doing hypothesis tests also. So skip all options, and the most common mistake that a student would make is pick option number 7. Do not pick option number 7. Even though we are using Z, which is standard normal, that interval doesn't apply here. Scroll down, go past T interval, and option A in my calculator is 1 prop Z int, or 1 prop Z interval. So select that. And it is asking for X, N, sea level, and that's it. So what is X in our problem? In our problem, X was 11. And what was N? 30. What confidence level did we use? 0.95. Enter. Enter. Is that very close? After rounding. So what we have there is 0.19. This is an approximate value. We have about 0.2 and 0.539, and here it is 0.54. Of the two, which is more accurate? Obviously the calculator, because it has 9 decimal places, or 12, I don't know, I think it's 9. But on an exam or homework, I would recommend retaining at least 4 decimal places so that your answer is as accurate as you could get. Does that make sense?